Well, we finally made it. Here it is, Chapter 12, the last chapter in Math 13 online class. So in this chapter, there's one main idea, and that is ANOVA. ANOVA stands for the analysis of the variance. Variance is the standard deviation squared. So I've got this example that I made up of 3 basketball players, and I went ahead and entered their data in list 1, list 2, list 3. For this one example, I'm going to go over the formula for analysis of variance so you have the idea of how it works. And then from then on, we're going to use the calculator to calculate the formula. So to begin with, I need to find the mean and standard deviation for each player. So this is going to be for player 1. So this is n equals 6 basketball games. The average is 29.167, and the standard deviation is 2.483. And then for player 2, find the mean and standard deviation. So again, n equals 6, x bar is 30.167, standard deviation 6.706. And then one last time. So this one has an average of 29. So again, n equals 6 games. X bar equals a 29.0. And S is equal to 6.099. So keep in mind that standard deviation is a measure of how consistent the list of scores are. So in here, we're talking about the mean. So this person, a little over 29 points per game. This one, a little over 30. And this one, exactly 29. So this person does seem to score more points, at least based on these 6 basketball games. But this person is much more consistent than these 2 people. If you look at the scores, there is some variation, but there's not a lot. Where this person could be scoring 23 points, or they could be scoring 39 points. A lot more variation. This one too, 22 points or maybe 39 points. So we're going to be testing the claim about the mean, but we're going to be doing it by looking at variances. So one thing to do is find out what is the variance for these 3 means. In other words, is there a lot of difference between these means? How much do they vary? So what I need to do is take those 3 and put them in a list. So let's see, I should have list 4, okay, and empty, there we go. So 29.167 and 30.167 and 29 exactly. And then if you find the mean and standard deviation for list 4, so that means that the overall average, which is called x bar bar, is 29.445, and then the standard deviation of the x bars, S, is equal to 0.631. Okay. Then the other thing that we have to do is find out, well, what is the average variance for these 3 scores? So that's called the pooled variance. So first of all, it's SP for pooled, in other words, putting them together in a pool. And we're using the variance. That's what this part says, variance. So variance is standard deviation squared. So we need each one of these squared, and then added together and divide by 3. So the average variance. So that's going to be 2.483 is squared, plus 6.706 is squared, and 6.099 is squared. Find the total, divide by 3. The average variance is 29.445. Okay, now we're ready for the test statistic. So the test statistic is the letter F, capital F for fun. And what it is you take this variance, so in other words, this is going to have to be squared, and you take this one and divide them, and then you need to know the sample size. Now, the formula is this simple, or should I say, is this simple, only if the sample sizes are the same. Otherwise, you have to do what's called a weighted mean, like if there was 5 games here and 6 and 7 games here, then you'd have to go 5 times this and 6 times this and 7 times this, and you'd have to create a weighted mean for all of it. But we don't need to do that because I just wanted to show you the idea of what's going on. So you're finding the variation between the means, so how much do these vary, and then what's the average of these variances. Okay, so that's going to be 6 basketballs per person. This one squared is 0.631 squared. These have already been squared, so I can just use this number without squaring it, 29.445. So we've got F equals 6 times 0.631 squared divided by 29.445. The test statistic is very small. The F distribution, because of the squares, it looks like the chi-squared distribution, and this is a right-tail only test, so alpha equals 0.05 will be in the right tail. And before we go on to the critical value, I want to show you how to use the calculator to get this number instead of having to do all of these computations over here. So in order to do that, you first have to have the numbers in the lists. So my numbers are in list 1, list 2, list 3. There's the original data. And then go to Stat, Tests, and it's actually one of the last ones, or actually is the last one. Oh yeah, we're at the end of the semester. Yippee. You hit the Enter key, and it tells you ANOVA for what lists. So then you tell it second, enter list 1, comma, second list 2, comma, second list 3. And then hit Enter. And it's going to give you a whole bunch of information, but we've got the test statistic F right there, 0.081. Then the other two things we need are degrees of freedom. So this is called degrees of freedom number 1. Scroll down, ignore that says error. This is degrees of freedom number 2. So we need degrees of freedom number 1 was a 2, degrees of freedom number 2 was a 15 in order to finish it up. And then you may remember the F distribution looks like this. This is in the back of my textbook. There's only two choices, that it's 0.05 or it's 0.025. Ours is right tail only, so it's 0.05. And we need degrees of freedom. The first one was a 2, and the other one was a 15. So here's the 2, and here's the 15. 3.6823. 3.6823. And then the question is, does this go past that? And the answer is no. So it's going to be failed to reject. We cannot prove anything. So in other words, these three basketball players' scores are so close, and there's so much variation that they don't really differ that much from 29.445, the overall average. Okay, on to the last example. So this last example is not only going to be an example of the analysis of variance, but it's going to be something that you're going to have to do on the last exam and on the final. And that is separate the data. So we've got their hours of work are right here. And I want to separate it for those that don't work very much, less than 10 hours, those that work 10 to 20 hours, and then those that work over 20 hours. And what I'm going to do is highlight them. So I've got a yellow highlighter, and that's going to be these people. If they work under 10 hours. And then when I highlight them, I'm going to highlight all the way across. So if they work less than 10 hours, so that's this person right here, but I'm not just going to highlight that, I'm going to highlight all of their information. And then this one, and this one, and this one. 6 hours, 6 hours, 0 and 0. So these are going to be the people that work under 10 hours. Okay. Next, I'm going to highlight using this red, these people. The ones that work 10 to 20 hours. So that's from 10 until 20 and including 20. So that would be this person. And including 20 means these three right here. And this person is next. $12, $14, $20, $12, and $18. And then everybody else would be working over 20 hours. So I just need to check that that's right. So over 20 hours, yep, 21, 32, 40, 42, over 20, 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 and over 20. Oh, here's another one, over 20. So then, the people have been divided into three groups. So we have those that have less than 10 hours, those that have 10 to 20 hours, and those that have over 20 hours. And so far, we can take a look and see how many people are in each group. So sample size for this one, sample size for this one, and sample size for this one. So first of all, these yellow 1, 2, 3, 4, 5, 6, 7, 8, 9. Then from 10 to 20, so that's the red ones. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And then for the black ones, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So let's see, this would be 15 people, plus 9 is 24 people. Let me double check. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32, 33, 34. What did I say before? I think I said 34. 25 and 9, 34. Okay. Whew. That's the hard part. Separating them. Okay, notice that I haven't even read the question. All I did was I looked at that part that says divide them. In the next 5 minutes I was doing that, dividing them. Now what's the question about? Tesla claimed that the mean, so that's a keyword, amount of units. So now what we have to do is look at the units. Don't look at anything else besides the units. How many units are they taking? So what I'll do is I'll put these in the calculator. This is going to be list 1. These people will be list 2, and these people will be list 3. Clear that. Clear this. Start fresh. Okay, so first, the ones that are yellow highlighted, units are going to go in to list 1. 17 and 18, 15, 12 and a half, 15, 14 and a half, 15, 11, and 19.5. Okay, those are the people that don't work a lot. How many units are they taking? Next, in list 2 is going to be the red circled or red highlighted people. So 15, 8, 13, 14, 14, 11, 12, 12, 23, wow, 23.5, that's a lot of units. And 17. And then finally, for the ones that work over 20 hours, so that's going to be these black lined ones. So 10, 12.5, 5, 12, 13, 16, 10.5, 12, 18, 12, 17, 14, 16, 19 is the last one. So this, I must have made a mistake. This only has 14 people in it. Well, let me go backwards through the list. 19, 16, 14, 17, 12, 18, 12, 10.5, 16, 13, 12, 5, 12.5. Oh, I didn't type this 5 in. I went 10 and then 12.5. Okay, so I need a 5 right here. That's cool, because now I can show you how to do it. So put the cursor where you want it, and then put second insert. It'll put a placeholder of 0 for you, and then you put in the number you need. So let me double check I have the correct number here. This list has 10 people. Yeah, that's right. This list has 9 people. Okay. So now we're ready to find the mean and standard deviation for each group. So this is going to be for list 1, the first people, they have an average of 15.278 units with standard deviation 2.623. Now do the same thing for list 2 people. So they average 13.950 with S equal to 4.14. And then for list 3. So now the average is down to 12.8 and S 4.157. So notice that the people that don't work a lot, oh, I'm sorry, that's not on the page. So the people that don't work a lot, they take 15 units. The people that work medium take 14 units, and the people that work more take even less units. So it's possible that we get reject here, reject that they're not equal. So the claim is that the mean, I'll just call this group number 1, this is group number 2, and this is group number 3. So mean number 1 equals mean number 2 equals mean number 3. That they all average the same amount of units. So one thing that people often do is they separate them correctly, but then they're so caught up on thinking about hours of work that that's what they type into the list. But this has to be units. This is about units. Oh, another thing that I want to point out is sometimes people go, oh, analysis of variance. That means I have to have 3 lists. So this is going to be list 1, this is going to be list 2, and this is going to be list 3. And then they do analysis of variance, and they get a test statistic of something like 178. And they go, well, critical value is 3.8, and I got 178, so wow, reject. But that's not correct at all. For one thing, are these even comparable? Can you say an hour of work equals a unit that you take? They're not even the same type of object. At least with these two, they are hours and hours, but these can't even be compared. They're not hours and hours. They're different units. So anyway, in here, this is how many units people are taking, how many units, and how many units people are taking. All right, then for the last part, it is the picture. We're using 0.05. Then we need from the calculator. Notice in this one also the sample sizes are not the same size. That's okay. You just put the numbers in the list like we have, and then ask the calculator to run the ANOVA test, and it knows what to do even if the size of the list are not the same. So the test statistic is going to be a 1.198. That looks like a fail to reject situation, but I need to finish it. So degrees of freedom number 1 is equal to a 2. Then scroll down. Degrees of freedom number 2 is equal to 31. Was that what it was on the last one? Oh well. Just look up the critical value. Again, with the F table, always make sure that you're looking at the correct page. And then we need 2 and 31. So 2 and... so they don't have 31, so I'm going to use 2 and 30. So that's a 3.3158. 3.3158. And so this is not big enough. That means failed to reject. So it looked to me like there is a big enough difference between these two, but then again, by only having 9 people and 10 people, it just seems like it's not enough data to actually prove it. But it was fun trying.